Good day and hello. My name is Brian. Well, I put up an interesting little video earlier, my project wind mapping, and I realized going back over it that same thing with a couple of my other projects. I realized this a little bit more when I did the project medical trapping. That's sort of just went blah, more than anything else. I didn't actually put a good structure to it. I didn't present it well. And there's a couple reasons behind that. Looking at the reasons, though, I realized that it doesn't really matter. I'll give you some of the reasons, though, so you can sort of see why it was presented the way it was. And very simply is, I think I got a lot of the pieces for how to put it together. It also segues into another project I'm actually working on. And the thing is, of course, I can see a lot of ways where it can be used, well, expanded upon probably be a better way to say, in improper way. And by improper, I mean it doesn't go the way, one, is I see it going, but two is also the use and abuse of it, I guess you could say, is not the way I see it should be used. So I'm actually going to go back over the project a little bit more in a slightly more presentation style. And part of that is I actually did write up some notes on it, and I'm going to break it up into different stages to make it a little bit easier to understand it. So this is my project wind mapping, Revisted. So, well, as I already said, it's many projects in one, or you can also look at it as a multi-stage project. The first part is actually a data sensor network. Later parts of the project use this first part in various ways. Benefits with minimal loss can be gained at each stage. Okay. The basic idea, which I did go over in the prior video, is to lay out a sensor grid over a certain location. I chose New York City for this example. Okay. From the data provided by this grid, one gets a map of the airflow, temperature, and other information within the grid network. This map can then be used in various ways. In air quality viewpoint, it makes it easier to trace contaminants back to their origin. Also, in the deal with, you can use it also for prediction of possible routes of air contagion that they would follow, such as the idea of CDC or different biological or chemical or nuclear contaminants. So like if there was something that happened, you can actually then predict outwards where it would actually flow through the city. But the thing is, you can also use it in reverse to say you actually take a reading someplace and you see contaminants. You can then trace it back to its origins. You can use it, once you actually have a map like this, is you can also study the sub-weather effects within the mapped area. Because you know how the wind flows, it actually affects the weather in different ways and also can cause different sub-effects inside the region that you're looking at. Later project suspension uses this data map or uses the actual data sensor network itself more directly to actually do some of these projects. Now onto the second part, which is the how. This is the part I've always actually been really reticent over talking about. Part of the reason why I've always been reticent is basically a partial fear of someone taking my idea and running with it and not getting me any credit. One. Two is also taking my idea and using it in a way I would see improper. Not to say that, way someone would use it would be improper, but looking at the way a lot of tendencies are and a lot of aspects are of what people do, I can definitely see a possibility there. I've sort of gotten over that partial fear. I still have it, but I've gotten over it enough to go, well, it doesn't really matter if I do it or if someone else does, because the benefits gained from this, I think, outweigh the costs if it's done the way I look at it. Obviously, certain costs increase if someone uses it improperly. So, very basic idea for how this actually works is you have a simple device. Probably, I'm not quite sure in the exact size. I've not actually built one of these yet. I've just looked at the theory, put all the different, I guess you could say, software code in place, and looked at all the different things that fit. The basic idea is, as I said there, is it has a wind meter, probably barometric, pressure gauge, all this other basic data that you can run into a simple system-on-chip computer, which is also tied to a Wi-Fi network. Now, that's the basic device itself. Now, the thing is, one of those isn't as effective as having a couple million of these, which is where a big project would come in, and also a good amount of jobs if you can do that. And from that, basically, is what you do is you basically drape it around the outside of all the different buildings. Now, I'm going to partially step out and actually explain one thing I do want to do with the device, which is have them powered off of the wind meter itself. Low power, system on chip, running a wireless network. Just a simple wireless device. All you need is to have a wind meter that generates enough electricity to power such a system. A lot of people usually say, hey, why don't you do solar with this? Well, I'm looking at the project as one single piece that works pretty much everywhere in this setup, and I'm using wind for the project itself. That's what it's doing. If you do solar power, well, think of the situation where it is. It's going to be on the outside of the buildings. Well, are you always going to have sun on it? Are you even going to have sun on it at any point in time? It's going to be in the canyons of the city. Now, the idea very simply is, of course, every, 50 to 100 feet long and probably every 20 feet up is you drape one of these. And since they're powered by the wind meter, they're not actually jacked into the building themselves. And since they also run off wireless, there's also another reason why you don't have to jack into the building itself. They all just basically communicate with each other. Now, of course, like I said, as you spread them throughout the city and every building, and from the information gathered is then sent to a central server, which correlates the data into the actual map. The devices themselves don't do any actual correlation. They just run the network and send the data to the central server. Now, from that data is what you generate the map from. You then, of course, have the general direction of flow, speed of flow, and any other information you can actually put in onto the sensors. Now, to reduce maintenance, you don't want anything that actually takes samples, because you'd then have to run around cleaning them out after a while. You actually want things that don't do samples. Things that run off their own. Now, the thing is also tied into some of the things that these devices could do is if a part of it fails, you could then, of course, have it send out a message saying this part failed, and you can actually go out and repair it. Also is if one of them dies on the network, well, the rest of the devices around it would be aware of this because they'd be losing data from it. There wouldn't be anything there, and you'd also get a signal that there's a signal lost. So you can actually then go out and also inspect the network. Now, looking at the devices on the software side, that's just the simple hardware side. This is where a lot of the interesting stuff came in. I looked at a couple different ways on how this would work. I made this a little easier, though, because one of my earlier projects and one of my continuing ones, actually I realized had a very close parallel for what would work best for this type of network, in my opinion. Now, basically, I was looking at a mesh network, or a mobile area network, as they call them sometimes too. The idea is very simply, it's a variation of the ad hoc protocol with an extra routing protocol added to it. The idea is, as opposed to the end user arrangement of the internet at the present setup, is instead of sending all commands to a tower, then relaying from the tower to the next station, in a larger end user setup, this is more of what the actual internet itself is set up in some ways, where basically each device appear and they all send each data to each other. Now, that actually has a very useful application in this for one of my later projects, but also in itself it also makes this system pretty self-reliant and also very versatile. Now, like I said, it has a lot of uses on that. Now, one is, at the basic level, it would be functional. Two is you can also use it to stress test various routing protocols over a certain amount of time, so you can actually then figure out what would be best on a scalability scale and everything else for this type of network. I did work out one small thing I would like to add into this network, which is a power feature. Because wireless in general seems to be rather power consumptive. Well, one way I was thinking is the listening aspect isn't that power intense. It's the broadcast that actually does. Well, I figured out a very simple, not like an algorithm, but very close, because I haven't actually put it down to numbers yet, of basically the power level of the transmit is related to, well, what's these different stations you can hear. And you actually reduce the power such, because with the neighborhood discovery protocol, I forget what the RFC is you send a packet out saying who you can hear, basically, stations within your local 1-hop radius and 2-hop radius for the neighborhood protocol discovery. Now, as in added messages, you can also probably list your power transmit level. Thing is, you actually get an echo back from another hello for whatever's closest near to you of what is the power that they see. Well, between those two things is you can then adjust the power level to a quieter spectrum, one that uses less power, but you're still heard by the network. And so you're basically not shouting at the top of your lungs every time you do it. Basically is, can you whisper versus shout? And it makes one for a lot less noisy network too, but also increases the reliability of the network, because the sound can, it can increase its voice, I guess you could say, for any particular device to the point where it knows it's being heard because its neighbors can hear it. But it doesn't have to shout every time, which also reduces the amount of power on the transmit. Now, that is just the first stage. That's just the hardware and the partial software for the mapping network. Now, the second stage is actually using parts of this data beyond the examples I gave, which is the, mapping of the network, tracing toxic elements, prediction of paths of toxic elements. Not really changing anything in our whole use. You're just using the data that you have. Now, the next stage, the reason I broke them into stages this way, is the idea of what other things you have to build to actually make this functional. First one is all you have to do is build the data sensor network and route it to that central server information to gather all this information. Second stage is, well, you now know what the air currents and airflow are through New York City. Well, once you know that, you can then start setting up duct work, air current flow, airline, different airfoils, everything else in different locations in New York City, and you can actually probably start directing the air currents inside New York City. Now, if you tie that in a real-time image to the map, you probably can actually have it, the air fluctuating in the ways that you want in New York City, such that instead of being knocked over when you walk around the corner of a building, you only have a gentle breeze flowing on the lower levels. And all the rest of the gusting air and the gale wind forces you can have always directed above and use it from there. You can then start directing the wind of New York City. Now, this, of course, can have a lot of benefits in a lot of different ways. The one example I like to push is the idea of powering New York City. I don't know how much power you get out of it, but that's the nice thing about this, is it's an addition. And you're not really subtracting anything from any of the power grid that's already existing. Well, the idea is, of course, is you have those really strong winds up above, and you direct them at a central building, which you mount turbines in. And, of course, the wind hitting the turbine generates electricity. Very simple. And from that, you actually increase the amount of power that is available to you in New York City. Now, like I said, I haven't actually run any statistics or any things on this to actually get an idea of how much the wind is, because first you need to get the map. And that was the second stage with wind mapping, which worked into wind power. Now, I have worked out a possible third stage, which some of you might key in on with my discussion of the device itself. That will be a separate video because it actually is more of a piece with a third project I'm actually working on and trying to figure out how to move forward on. I hope you have a beautiful day.